Okay, 3x minus 1 over 2x plus 5 times 3x minus 1. There's nothing really tricky about this. People just make a silly mistake sometimes. So what's going to happen here is these guys are going to cross out. And sometimes people take the 2x plus 5 and they teleport it to the top. But that's not the case, of course. What we actually end up with is 1 over 2x plus 5. So this and this are equivalent. The other interesting thing is, of course, we have some slightly interesting restrictions. 2x plus 5 is not 0. 3x minus 1 is not 0. So 2x is not equal to negative 5. X is not equal to negative 5 over 2. 3x is not equal to positive 1. X is not equal to a third. And putting that all together, we say that this and this are equivalent as long as x is not equal to negative 5 over 2 or a third. Example 20. 18x minus 9 over 4x minus 2. The x's here do not cancel with each other, so we're going to have to do something. We're going to take a common factor out, so we're going to end up with 9x minus 2x minus 1 over 2, and that's going to leave 2x minus 1. These cancel, and so this is equivalent to this. These are exactly the same thing. 18x minus 9 is equal to 4x. 18x minus 9 over 4x minus 2 is equal to 9 over 2. There are some restrictions. The bottom cannot be 0, so the bottom cannot be this. So x can't be 2 over 4, which is just a half. So this is equal to this as long as x is not equal to a half. Okay. Now this one's even more complicated. So we're going to have to factor that top thing, and you may have learned different ways of factoring it. I am going to factor it in my way, but you may have learned a different way. So it's going to be minus 7 plus 1. And you may have used this is complex factoring, so you may have used decomposition or a box method or a guess and check. Whatever your method is, you're going to factor it. And it turns out this factors into 3x plus 1 times x minus 7 over 3x plus 1. And by the way, we kind of knew that 3x plus 1 was going to be a factor because we wanted something happy. We wanted something interesting to happen. If these weren't the same, nothing interesting would happen. These cancel, and we end up with x minus 7. So this is equivalent to that. There's a restriction. The restriction is that 3x plus 1 is not equal to 0, so 3x is not equal to negative 1. So x is not equal to negative a third. So this is equivalent to this as long as x is not equal to negative a third. Example 22. Okay, so these look like they almost cancel, but not quite. Like they're almost the same, but they're kind of opposite. And we're not quite sure what to do here. So what we're going to do is we're going to do a trick. And the trick we're going to do is we're actually going to factor out a minus 1. You can do it from the top or the bottom. I'll do it from the top. We factor out a minus 1 from the top. That gives us minus 2x plus 3 over 3 minus 2x. And what I'm going to do now is I'm going to change the order of the two things in the bracket. So it becomes 3 minus 2x over 3 minus 2x. And look at that. So by factoring out a minus 1, we can actually change the order. And that only works when you have subtraction. For addition, if you factor out a minus 1, you wouldn't change the order, you would just make them both negative. These guys cancel, and all you're left with is minus 1. So 2x minus 3 over 3 minus 2x is actually equivalent to minus 1 with a restriction. The restriction is that 3 minus 2x cannot be 0, minus 2x cannot be negative 3, so x cannot be positive 3 over 2. So this is equivalent to this as long as x was not equal to 3 over 2. And that's it.